I'm NK. Welcome to our family. In today's lecture, we are solving out the question related to the differential equation. Question says that solve the following differential equation: dq plus dA square into y is equal to sin ax. At first, write down the auxiliary equation, that is become capital D is equal to m, then m cube plus ma square is equal to 0. M take out a common, then m square plus a square is equal to 0. Now m is equal to 0 and m is equal to plus minus a iota. When m square plus a square is equal to 0, we get m is equal to plus minus a iota. So it's a cubic equation. Then we get three roots in which one is the real and two are the imaginary. When we know that when the roots are real, cf is equal to c1 e the power ax plus c2 e the power bx plus c3 e the power cx, so and so. And when the roots are conjugate and imaginary, then e the power alpha x bracket c1 cos beta x plus c2 sin beta x. So cf is equal to c1 e the power 0x plus e the power 0x c2 cos x plus c3 sin x. When we solve out, we get c1 because e the power 0 is always 1, c2 cos x plus c3 sin x. Now find out the pi. For finding out the pi, write down the RHS part of the given equation in the numerator. So sin x in numerator upon dq plus dA square, the LHS part of the function of d. Now we get, take out d as a common. Take out d as a common. Then we get d as a common, then we get d square plus a square. Now apply the function and solve out. Then we get function says that if sin ax in numerator upon d square plus a square in denominator, d square plus a square, then we can write down minus x upon 2a cos ax we can write down. Its identity says. Now when we apply, we get pi is equal to 1 upon d is as it is, so 1 upon d is as it is. Sin x upon d square plus a square, we can write down minus x upon 2a cos ax. D stands for differentiation of the given function with respect to x. When we take out upper side, it's become the integral. So pi is equal to minus 1 upon 2a is the outside, and the 1 upon d become the integration of the given function cos ax with respect to x. So cos ax dx. Take out. Now we solve out this integral by the eilate. Eilate says that take out the algebraic function is first and another one is second. When we solve out by the eilate, we get pi is equal to, I think you everybody know how to operate the eilate. Pi is equal to minus 1 upon 2a is as it is, so minus 1 upon 2a. Eilate says that write down the first part as it is x, and the integration of second part, that is cos ax with respect to dx minus integration differentiation of the first function, that d by dx. Here the first is x, so x, integration of second, that is cos ax and dx, and the integration of both. When we solve out, we get pi is equal to minus 1 upon 2a is as it is, so minus 1 upon 2a. The differentiation integration of cos ax is sin ax upon a, so it's x upon a sin ax minus the differentiation of BC is so 1 and it's become 1 upon a sine ax and the integration of given function with respect to dx. When we solve out, we get pi is equal to minus 1 upon 2a x upon a sine ax. The integration of sin x is cos ax, so plus cos ax upon a into a become a square, so a square. When we solve out, we get the pi is equal to minus x upon 2a square sin ax minus 1 upon 2a cube cos ax, so cos ax. It's over a pi. Now general solution is given by hence GS stands for general solution is, we know that general solution is given by y is equal to CF plus PI. CF stands for complementary function plus PI stands for particular integral. So y is equal to, at first write down the CF. CF is C1 plus C2 AX cos AX, C1 plus C2 cos AX plus C3 sin AX minus x upon 2a square sin AX minus 1 upon 2a cube cos 1 upon 2a cube cos AX. Some books gives the solution as a cos AX is submerged and it is write down as a capital C. So y is equal to C1 plus cos AX, then take out common, then C2 minus 1 upon 2a cube and it is become as a cos AX plus C3 sin AX minus x upon 2a square sin AX. We don't take the sin AX is common because it's also having the one algebraic term, that is 1 minus k x upon 2a square. So don't take it as out a common. Now we solve out it and get the complete solution. Here C2 minus 1 upon 2a square is a arbitrary constant. We can take out the capital C as a terms. Then y is equal to the complete solution is C1 as it is plus we can take capital C, so C2 cos AX plus C3 sin sin ax minus x upon 2a square sin ax. That is our final solution. I think you understand how we can solve out the given question and find the solution. C1 plus C2 cos ax plus C3 sin ax minus x upon 2a square sin ax. This is our final solution and it is the way by which we can solve out the given question. Now our lecture is finished. Jai Hind, Jai Bharat.